Okay. So does anyone have any questions about part one?
No, part one was pretty easy.
Oh, something's happening. Hold on 1 second.
Maybe I got an email.
Um, what about part two?
On question 1, how do you figure out D?
It's just something I wrote down in my notes because in the reading or in the book, where is it? I have this written down. It says that if you jeez, I wrote this down somewhere. Oh, okay. So it says that if the value of I forgot what that is. The level of significance, if the number is small, then there will be the probability of a type 2 error will be very large. You would need to,
It also says when one probability goes up, the other one has to go down. So because it says that if we wanted to decrease it, the other one would have to be increased.
Okay.
I guess I don't know what your question is.
I don't know how to get the D.
How to get D?
Yeah.
Hold on.
Probably the stupidest question I could have asked, but
Wait, are we talking about the same D?
1D.
Yeah.
yeah.
on part 2.
So just increase the level of significance.
Yeah.
Um. So I guess the way I did it was I just flopped what it said in the book because the book was for type 2. Hold on. Where is my book?
Probability of making it higher increase or decrease.
Yeah, like it says in the memory aid, if the P is low, reject the null, but we don't want to reject it, so then you'd have to increase it.
Okay. Simple enough.
I had a question about what the freak is happening on number 4 of 2, Roman numeral 4, how they got that answer, because I typed in like 1,000 things and I could not get that answer. I got a lot of other answers, but not that one.
Can you say number 4 of which one is it?
Yeah, part 4, number 2.
These are numbered weird, so I was like, crap.
IV or whatever.
Oh,
Yeah.
okay. Compute the test statistic. What is the formula to be used?
I guess I don't really know what to put in the value. Like we have the mean and the standard deviation, but I don't know what the value is. Like if they, because it's, he wants to know anything other than 47. So then do you put, like I even tried 46, I tried 48, I tried the 2 different standard deviations we had, and my answer didn't come up with 0.209. Natalie, you're smart.
No, I'm not. I didn't know how we came up with 209 either. And that was going to be my next question. So we can either be really stupid together or something else.
Did any of you, did you, Sydney or Dana, get 0.209?
Sorry, for which? Oh, I see which question. Okay. I didn't actually do this question for some reason. Let's see if I can do it real quick.
Did you use a program to do it?
Sorry, what?
Did you use a program to do it, like Excel or anything? Or SPSS?
Well, it's just how you do the z-score.
Yeah, I know.
So I just use the calculator.
Okay.
I guess I don't really know what to put in the sample or the value number. Like I even broke it up like how we've tried to find the value before, like multiplying by the standard deviation and stuff. And the answers that they got was 27 point, hold on. 27.445, but I don't know where they got that from.
47. That's the mean.
Wait, what? No, I'm good. Thank you. We might ask you when we're done with this, though. Or whenever you get home. Oh, okay.
I keep getting a negative. Then again, I'm putting in like you said, like you tried most of them. That's what I'm trying right now. I cannot find. Let me do this.
Um, Wait, what is this question even asking for? I'm so confused.
We want to find the z-score.
Okay, so I understand that you have to use a test statistic formula, but okay. What is? So I know in the book it says that, well, it's obviously not giving us a sample statistic.
Mm-hmm.
Always point. Um,
I got close to it.
I don't know.
Did you guys put put whatever you guys got into the applet?
Put what in the
What
applet?
value would you be using?
Well, for the applet, we put in the, that's the next question. We put in the p-value. But, like, in order to know the p-value, no, you don't put in the p-value. You put in whatever answer you got for 4. So you can't use the applet until you know this answer.
Yeah. Okay. Because that's what I did. I actually put it into the applet, and then I got like 0.22, and I was like, okay, that's close enough. But I don't think it's right, obviously. I don't know how to do this. Wow, this one's weird. It doesn't even give us like all the numbers for this formula.
Yeah. Oh, crap. Okay.
Ah! Why?
Yeah, no.
Ah.
I can, like, if we don't figure it out, I can just send him an email and ask him if we just wanted to try the test.
I may have gotten it. Just a second.
Yes. Okay. I don't know. Okay.
Does he put videos up of the answers to the or how to work out these problems?
No, he just gives us the answer sheet.
I'm getting close to it, but I'm not getting exactly it.
What are you What numbers are you using? Or how are you putting it?
The only thing is I don't. A z-score can't be. Well, yeah, it can be. I think he may have forgot to put the negative number inside of it because you take 46.733333 or whatever minus 47.
Yeah.
And then all over 5 divided by the square root of 15. And you get negative 0.20656, which would be, I mean, it's kind of close, but I used the right numbers, so I don't know why.
Where did you get 46 point, whatever you said?
It's the
Yeah.
mean that they give us in the chart.
Yeah, it's the mean.
Ow!
You take the mean.
I've been using the number 47.
Nope, that's the hypothesis.
Yeah. So I took the mean minus the average, and then divided it by the standard and then all of that divided by the standard deviation.
Oh, I got it! I got it! I got it!
Scared the crap out of me.
Sorry. I got the answer.
Okay, wait. What did you do? I'm sorry. Divided by what? What did you divide by?
So divided by standard deviation divided by the number of
No, but what did you plug in? That's what I'm saying. It's like,
um,
alright.
so the 46.733 minus 47 divided by 5 divided by the square root of 15.
Just 5 or 0.05?
5.
What did I do?
Wait, where did you get 5 from?
5 is the standard
Top of the
deviation.
study.
What?
But I got it from the top of the study.
5 is the standard deviation.
Yeah.
Deviation.
You guys. I got the right answer.
How'd you do it?
Just swap the numbers you put. Do 47 minus 46.73.
But that would be backwards, wouldn't it?
Yeah, you're like, that's not the formula though. That's weird.
Oh, no, because... Hang on. I think I might have...
Do you get it?
Well, because...
No,
no, that doesn't make sense. Just kidding.
No, because like the 46.33 is the mean, so you would do the 47 first. You would do the hypothesis first.
But, okay. Alright, well, I'm just, because, like, the way I wrote down the formula, it says that the mean is first and then it's the hypothesis.
No, it's the value, and then the little squiggly thing is the mean.
Okay. I'm sorry, I just got this from the video tutorial. Maybe he just does it.
Oh, just kidding. You're right. Oh, no. No. 47 minus 46. Divided by the square root of... Wait, what did I just do?
You don't even know.
Did you guys get that too?
I got 0.206. Well, in that case, 7. So I got close to it, but
If you do 47 minus 46.73 divided by 5 and the square root of 15,
yeah.
you'll 0.2091.
Ah.
Well, 20914. But
Yeah, I'm doing that right now. 47 minus 46. 0.27. Oh, well, that's probably one.
That's definitely not what I got, because I got 0.5189.
I got it. 0.20914. Woohoo! Just cut it off after 2 digits then. Seven. What? No, I don't like women at all. So.
did you get it, Natalie?
I'm getting 0.5.
That's what I'm getting.
So you did
So 47 minus 46.73, right?
Mhm.
And then all over 5 divided by the square root of 15.
Mhm.
Sweet. That's cool.
Yeah, I'm not. I can't get a 0.5.
Get out of my game. Yeah, they can hear me.
What y'all are doing? Five, square root. 40
Close my door.
minus.
Out of here.
Oh, okay, I got it now.
Roommates are crazy. Okay. Okay, so I'm just wondering, back to the formula that we used. So I can't speak. Okay, so it's the value minus the mean.
Yep.
Okay. It's confusing.
And then, so I put the value in the mean in parentheses and then divided by 5 in the square root of 15. And that's what I got.
Okay. Okay, so that thing that looks like a U is the mean.
Yep.
Yep.
Oh, that's confusing. Because, like, in the video tutorial, it showed us that was the hypothesis. And the mean was the X bar. So, I don't know why they be tripping.
Oh.
I don't know. Alright, okay. Anyway. So, now that we have it, 0.209.
Do you have any other questions?
No.
0.8. What? 0 equals 0.8337.
Did we just move on to the group quiz?
Yeah.
Are you ready?
Yeah, I'm good.
Okay. Here we go.
And
Okay, let's see.
No!
what happened?
It timed me out.
What?
I got timed out of, not my quiz, of the online.
Oh.
I gotta re-sign in. Don't mind me. Okay. Okay, I'm ready.
Okay, I started it.
A hypothesis test consists of two hypotheses, the null hypothesis and the alternative hypothesis. Which one represents the status quo? The null hypothesis. That's what I said.
Yeah, that's what I said too.
Yeah.
Which hypothesis involves equality? Isn't that on the null too, or am I spacing it? Yeah, the null is the equality.
Yeah, because the
Yeah.
I'm trying to take a quiz, guys.
The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer question 5. When computing this probability, which hypothesis do you assume to be true?
The null? Or is that the one that we reject and not reject? Because we need evidence that it is not true. Or not.
See, I don't think it's the null hypothesis because it says at least.
At least?
Yeah, and that makes me think of those little greater than or equal to signs, like greater than or less than signs.
Yeah.
Actually, in the book, it is the null.
What does it say?
It says when we test hypotheses, we assume the null hypothesis is true.
Unless we get evidence.
But in order to determine the p-value, you use the alternative hypothesis. So you always assume the null is true, but you use the alternative hypothesis to compute it.
What? What?
I don't know.
In the book, it says the p-value is determined using the alternative hypothesis, but you always have to assume the null hypothesis is true.
So it is the hypothesis.
Yeah.
So it's null, not alternative?
Yes.
Okay.
Number 6. Suppose the I can't talk. Suppose the null hypothesis is the null hypothesis of the mean or whatever equals 10. Okay. I don't even know what the mean equals 10. Failed test.
What?
Wouldn't that be not equal to?
Yeah.
Okay.
Let's see, left tail.
It's left-tailed.
It would be the mean is smaller than 10.
And so then right would be greater than?
Yeah.
The outcome of the hypothesis test is determined by comparing the p-value to the level of significance, or alpha. Use this information for questions 9 and 10. Which relationship would result in failing to reject the null hypothesis? Oh. So if you fail,
Wouldn't that be oh wait, failing or rejecting. Okay, never mind.
It's less than, right?
Less than alpha or Z?
it should be alpha.
See that it means that the Z score is large. So
Wouldn't
if
it be?
I don't know.
Oh, okay, I see.
It would be. It wouldn't be alpha, right?
I don't think so.
I just remember hearing something about alpha in the video.
Oh,
I watched the videos.
okay. So if p-value is less than alpha, reject the null hypothesis. So p-value is greater than alpha, then you don't reject it.
Where are you reading it?
Well, I'm reading it from my notes, but it was in the book.
The book or the video?
The book.
Okay, sorry about that.
So you
Okay,
said
so-
what? Sorry.
If the p-value is less than alpha, reject the null hypothesis. But if p-value is greater than alpha, don't reject the null hypothesis.
So the p-value being greater than alpha is going to fail to reject it.
Yes.
So is it? Crap, never mind.
And then 10 would be the opposite.
Yeah.
Oh, I found it. Yep.
What part is it in, Diamond?
4.4. Right under the.
Oh, okay.
the
Yeah.
PSO.
So it is p-value greater than Z? Wait, is that what? Sorry.
P-value is greater than alpha.
Okay. And the second one is less than alpha.
Yeah. So an insurance company is reviewing its current policy rates when originally setting the rates. They believe that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Use the information for questions 11 and 12. Which of the following would be appropriate alternative hypothesis? The average claim amount is greater than $1,500, right?
When
Or is
it's
it not
equal to?
Yeah. Well,
Yeah.
is it equal to or not equal? Because it sometimes it allows both, right?
No, the alternative is always going to be not equal.
Oh, okay.
Yeah,
Got it.
because if it's equal, that'd be the null hypothesis.
Which is the second one. So the second one is equal to.
Mm-hmm.
Yes.
Wait, what is?
Wait, actually
So-
higher.
So isn't it supposed to be higher because that's what they wanted?
Yeah, that's what I just saw. So now I'm confused.
Because they are concerned that the true mean is actually higher.
Yeah. Let me double check the book.
Because that's like left wing and right wing.
Yeah. I would vote the greater than 1500. Yeah.
Okay.
But that's me.
So
I don't
the
know.
first one is not equal to, and the second one is greater than.
No, the first one is number 11 is greater than.
Oh,
And then equal to.
And then number 12 is equal to.
oh, okay. All right, 15. The insurance company randomly selects 40 claims and calculates a sample mean of 1,650. The insurance company assumes the distribution of the sample is normal. Is this a good assumption?
Because looking at the next question, it's going to ask if it's the law of large numbers or if it's the central limit theorem.
It's the central. Because the central deals with distribution.
So 13 is yes, and 14 would be central limit theorem, right?
Mm-hmm.
Okay.
And then the test statistic is Z, right?
Yeah. A historic mean of sales receipts at a grocery store is $150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with the following hypothesis. The null is that the mean is equal to 150 and the alternative is that it's less than 150. She will use a level of significance of A.005. She then takes a simple random sample of 36 sales receipts from her store and computes the value of 144. Use this information for questions 16 through 18. What is the Z for?
Okay.
So it's going to be 150 minus 144 on top, right?
Yeah.
I thought it was supposed to be the opposite. Because it's asking for a test statistic, right? Because the test statistic formula is x bar minus mean.
Yeah, but I was saying that because when we were trying to figure it out in the prepare assignment,
Mm-hmm.
they're like, wait.
But which one are we supposed to use? Because the book says it's x bar minus mean.
I don't know.
Yes, we can.
Let's try doing
Right. I think it's 144 minus 150. Divided by. However, is there not an n value?
The n value is 36.
It's 36.
Mm-hmm.
Did I just miss that? Okay. 44 minus 150 divided by...
Well, either way, you're going to get 0.9 negative or positive. So it's
Yeah.
2.
So the z-score is 0.9?
It's 150 minus 144 would make it 0.9, but 144 minus 150 would make it negative 0.9.
Let's do it negative point or negative 0.9 because that's what it says in the book.
Okay. And then I'll put that in the applet,
Can you
which
put 0.900 or can we stop at 0.9?
I think just 0.9.
Okay.
What is the p-value?
Only looking for the left hand side to be shaded.
Yes.
Just the negative part, right?
Yeah.
0.184. Is that what you guys got?
1 second. Wait. Hold up. 1 second. Yeah. Where did it go?
Yeah, you just shade the left side.
Yeah.
Yeah.
So it's just 0.1841.
But it only asks for 3 decimal places.
Yeah.
So 0.184, correct?
Mm-hmm.
Okay.
What did you make about the null hypothesis for this problem?
So she said it's 0.05, and we have that it's more than that. So we would reject.
Yeah.
Okay. Then number 19.
Rejecting the null hypothesis when the null hypothesis is true. That's a type 1, right?
Yeah. Reject when we know it's true, it's type 1. If a researcher decided that instead of using a level of A equals 0.05, he would use A equals 0.01, which of the following is true?
So, yeah. Where are we at somewhere? A type 1 error would... Oh, no, that's decreasing. A type 2 error would increase, right?
That's what I'm thinking.
No, it will make it harder to reject. Where am I?
What?
It's what?
Wouldn't a type 2 error increase because it's getting... The level of significance is getting smaller. So...
I don't know. In this box in 4.5, I'm just reading the box. It says that if committing a type 1 error is undesirable, why can't we let alpha equal 0? This would make it impossible to commit a type 1 error. And then it says, actually, this would make it impossible to reject any null hypothesis. But that's only if it's 0.
Yeah. It also says somewhere in the reading that common values for the level of significance is 0.05, 0.1, and 0.01. So...
Yeah, I'm looking at that right now because that's the same spot that she was just reading in 4.5, but...
So then what?
So
I'm
type
pretty sure the probability of a type 2 error would increase.
So,
I think it's the type 2 error will increase, just because whenever we reject a true null hypothesis, we say the type 1 error was committed. And so if it's going to be the opposite of that. Does that make sense?
Yeah.
wait, isn't it D? His experiment will be more scientifically valid because we're making it, because it said this would also make it impossible to reject any null hypothesis, which would make it more valid.
I have no idea.
I don't know. Which one are we going to go for? Pick one.
I don't know.
Right, why don't we just skip it, go to 21, and then someone submit, and then they can tell us what it was.
I don't know.
Because that's really confusing. That's like...
So if A equals 0.05, compute the probability of committing a type 1 error.
Do we just put that in the applet?
Wait, what? What'd you say?
Oh, never mind.
Oh, okay.
On those, don't we just transfer it to percentage? Yeah, because in part 2, question 1, on question C, it was if the analysis were done at an A equals 0.01 level, what is the probability of committing a type 1 error? And it's a 1% chance.
It's 1%, yeah. So then it'd be 5%.
5%.
We have to put the percentage sign? Oh, it won't let us.
Well, 5 is going to have to do, so...
Alright.
Okay. What did we say for 20?
Oh, I would just like to say that 20 is the one that, what's her face said? Gosh, I can't, Sydney said.
Is it the probability of type 2 error will increase?
Yep. And 5 is just not going to do it.
What do you mean?
It's wrong. If you guys haven't submitted yet,
0.05 was the correct answer for 21.
So we just had to put it down again?
are you serious?
Yeah, because
Ah!
it's not asking for a percent.
We should email him.
Did it in the homework? Yeah, I'm going to email him because if that's what it says in the homework, then I can't remember what I closed my homework.
This question wasn't asking for a percent. It was just asking.
No, but in the homework, did it ask for a percentage? I'm just wondering.
No, it says what is the probability of committing a type 1 error?
Oh. Ah. Okay, well, I'll email him about it, see what he says, and then I can...
Why did we get 18 wrong?
18?
18.
Yeah.
18. Rejected.
Oh, it's failed to reject?
Yeah.
Yeah.
This problem. I don't know. Those things are confusing. It's like saying the same thing. Fail to reject and it rejects. I don't know.
It should be reject though because it's higher, right?
Yeah. It should be. Because if we got the p-value right, so, and if alpha is, because the p-value is greater than the level of significance.
So for 16, did you guys put 0.900?
I put negative 0.9.
Yeah.
Oh. Okay.
Yeah. No, wait. Hold on. The answer is fail to reject?
Yeah.
How come on the test that's or on the practice exam or whatever,
The homework?
that's right. On the individual, if we do question number 2, part 6, the p-value is supposed to be greater than the level of significance.
Oh.
So that makes sense that the answer is fail. Because the
Wait,
p-value
what?
I'm just writing these all down so I can email him because like, please teach me.
But doesn't the book say the opposite?
No, they're both the same. Because on the practice test, the p-value is greater than the alpha number, whatever, and the answer was fail to reject.
Maybe I just wrote my notes down wrong. Huh. I'll look that up again.
Yeah, because if the p-value is greater than alpha, we fail to reject the null hypothesis.
I think I might have just written it down wrong then.
Wait, hold on. On the exam, on the quiz we just said,
Oh no!
we just said to reject it, but it is higher, so it's supposed to be failed to reject.
Yeah, it's supposed to be fail to reject. We said reject because it's higher, but that's wrong.
Oh,
We're
okay.
saying fail to reject because it's higher.
Okay.
So
Got it.
so we got that wrong. Well, okay, peeps. Unless we have any more questions.
No.
Searching through.
I'm good.
Adios.
Bye, everybody.
Bye.